In this lesson, we're going to take a look at some quadratic word problems and talk about different parts of these word problems that we can find, or different parts of your quadratics that we can find. So quadratics, we're going to find graphs of pretty much everywhere in the real world. And so these will all be created or be able to be created using quadratic equations to get the shapes of these types of parabolas. So firstly, let's talk about what the x and the y mean in quadratic functions. So the x-coordinate, which is represented on your x-axis, is always going to be the variable that is in the quadratic standard form of ax squared plus bx plus c. What you'll find as we're doing word problems is that they may not use x in these places. They might use t to represent time, or s to represent seconds, or something like that. So if x is not actually used, you can refer to whatever variable is in the place of where x would be in standard form as the x variable. So for example, if the formula for a word problem was d equals negative 16t squared plus 6t plus 5, then the x-coordinate would be which variable? Well, if you're looking at standard form, which is ax squared plus bx plus c, you can see that in the place of x is t. So t would be the variable there that we're working with. Okay. The y-coordinate, which represents the value on the y-axis, is always the variable that is not in the standard form, ax squared plus bx plus c. It's the y equals portion. So it's whatever that equation set equal to represents the variable for the y. So the y-coordinate would be, the d in this case. Okay, so when I'm referring to x and y in these equations, you're just looking for what the x and the y would be if we were dealing with standard form. I'm not sure why this is going crazy here. Okay, anyways. So now let's talk about, when we're analyzing word problems, what the maximum and minimum mean in a quadratic function. So remember that the minimum and maximum of a quadratic do represent your vertex of that parabola. It's a high or a low point. So the vertex is one coordinate with both x and y. So make sure you know which one you need to answer a word problem. Each letter stands for something different. So if you've got your vertex as the point x comma y, what I mean here is that a highest point on that parabola will have a time it took to reach that high point, and will have an actual height. And so x might represent your time while y represents your height. And so if the question is asking you to analyze what the highest point is, well, then you would want the y portion of your vertex. But then if it was asking how long did it take to get to that high point, well, in that case, maybe the time variable is your x, and so you're really looking for the x portion of your vertex. A lot of this we'll be able to figure out from looking at a quick sketch of what's going on and determining which piece of your vertex you need. If you do need the x portion of your vertex, remember that the x part of your vertex is found by using the vertex or axis of symmetry equation of x equals negative b over 2a. If you need the y portion of that vertex, meaning it's like a height or a distance or something, then you would still have to do this, okay, to find the x, and then plug the x value, or substitute the x value, into the quadratic equation to solve for what the y would be. So you'll just have to determine which piece of your vertex you need. So let's take a look at an example. A model rocket is launched with a velocity of 64 feet per second. The equation h equals negative 16t squared plus 64t gives the height of the rocket in h in t seconds. So this is telling you height should be feet. It's telling us units and everything here, seconds after it is launched. So let's say in this scenario we're looking for what the highest point that rocket reached was. So what is the rocket's maximum height? If we're looking for a maximum height and we're thinking about a rocket being launched, means it's going up and it's coming back down. The highest point would look like somewhere like that on your parabola, which is a maximum point, which is another name for it is your vertex. So here's a scenario where to answer this question, we will need the vertex of this parabola. But we have to determine which part of our vertex is going to help us because a vertex is a point, an x comma y ordered pair. So in this scenario, we've got h equals, remember that's really your y, and x equals. Well, x in this scenario is t, time. That's a seconds. That's a unit of seconds. So if we're wanting to answer what is the rocket's maximum height, time won't really tell us height. Time might help us figure out the height, but the variable we're really going to be looking for is the y of our vertex because y represents height in this case. So this means vertex and specifically means to get the y portion of the vertex. To find the y portion of your vertex, though, we do have to know what the x value is. So you're going to use your axis of symmetry formula of x equals negative b over 2a to find what the x value would be, and then use that x value for your vertex to substitute in for t and solve for h, the y. Remember, x and t are interchangeable, h and y are interchangeable. So in this equation, a is equal to negative 16, b is equal to 64, and there is no c listed, but it would be understood to be 0 if we needed it. So let's now replace negative b with negative 64 over 2a, 2 times negative 16, and simplify to get t to be equal to 2. So t is 2. You can also think of this as x is 2 for your vertex. Again, this is not the answer to this question yet. We're using x to help us get the y, that high point of our vertex. So if this happens, if t is equal to 2, this means that at 2 seconds, that's when the rocket will reach its high point. So now we'll take our equation, and instead of t, we will replace each t with 2 and simplify and solve for h. So in doing that, we should simplify to get this whole thing equal to 64. And that tells us that the height of the rocket at 2 seconds, or at the vertex, is 64 feet. So together, oh, I had it written over there, but together that means your vertex is the point 2 comma 64, and the 64 is the piece that told us how high, because y stood for height. All right, let's add on to this. So now we're asked, what is its height after 1 second? When you're being told to find a value at a certain time in this situation, what you need to think about is, okay, which variable does 1 second would it go in the place of? So a second is a unit for time, meaning that this is really asking us to find h when t equals 1. So if t equals 1, we will take our equation and now replace each t with 1 and simplify and solve to get our h. So here negative 16 plus 64 gives h to be 48. So that means that at 1 second the rocket reaches 48 feet in the air. All right, so units are really important for breaking down these word problems. Suppose a tennis player hits a ball over the net. The equation h equals negative 16t squared plus 9.4t plus 1 gives the ball's height h in feet at a time t in seconds. So in this problem, we're being asked how many seconds did it take to reach a height of 2 feet? Here we have t and h again. H stands for y, and the t's are in the place of our x's. So if we're being asked how many seconds, well, seconds is t. That means What is x? Did it take to reach a height of 2? Well, height of 2 means that was your h or your y in standard form for this quadratic equation. So if the y is 2, that means we're going to replace y with 2. And in this scenario, we need to solve for t. So this is where our solving methods are going to be really helpful here. Because to be able to solve for t, we're going to need to be able to find its possible solutions. So that means we need to set the quadratic equation equal to 0 and then factor if we can. If we can't, then we would use our quadratic formula. Now, because the middle term is a decimal, that means we can jump straight to our quadratic formula because we're not going to be factoring decimals. So from here, we've set the equation equal to 0 by subtracting 2 from both sides, which is what turned this plus 1 into a minus 1. A is equal to negative 16. B is equal to 9.4, and C is equal to negative 1. So at this point, because we can't factor, we will use our quadratic formula of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplify all those portions, so substitute into your quadratic formula using parentheses carefully with negative signs. And from here, you'll simplify your 3 chunks to show your work. So if you need to use your calculator for your discriminant, that portion under the radical, that's fine. So your chunk should simplify to negative 9.4 plus or minus the square root of 24.36 over negative 32. At this point, we're wondering how many seconds did it take to reach a height of 2 feet? Well, if I think about this ball being hit, it's going up and coming back down. So your or wherever you're starting from is probably being hit above the ground, right? So our x-axis is probably like down here, and this might represent your starting point, but it's not necessarily your y-axis in this case. So we're wondering, when will it reach 2 feet? Well, it's going to reach 2 feet, and this really implies on the way up. So it might reach 2 feet around here. It's also going to hit 2 feet on the way back down as well. But if we're, we have to look at the language being used. If we're being asked, when will it reach that 2 feet? That means on the way up, how long does it take for it to reach 2 feet? So find both your roots, but the first one, the first time that we're given here is 0.14. That's going to be the one where it's reaching the 2 feet. On the way back down, it will reach 2 feet at 0.45 seconds again. So for this type of scenario, I would probably just give it will reach 2 feet at 0.14 seconds. But it would be fine if you did state both times that it hits a height of 2 feet as well. So if you did say both times that it would happen, that would be okay as well. Okay, again with this same problem, now we're wondering how many seconds was the ball in the air until it hit the ground. This one's a little different because we are not given any numbers in this question. So we don't really know exactly, like here we were told, okay, 2 feet, before we were told 1 second, and things like that. So here we have to really think about, what does it mean to hit the ground? And if we're hitting the ground, we may not know how long it takes for that to happen, but at the ground, our height is equal to 0. So the ground has a height of 0 feet. We do not have a height there. So the ground's value, or the height there, would be equal to 0. So what this implies to do is to set your equation equal to 0 and then solve for the time. The how many seconds, that's what is t. What is your time? So set it equal to 0. And now we solve, and in this case now A is negative 16, B is 9.4, and C is positive 1. That's a C, is positive 1. So we, again, because of the decimal, will jump straight to our quadratic formula. How about take a moment and substitute all the portions into your quadratic formula. Simplify your chunks. So click pause, do all that. When you're ready to check that, let's click play. Okay, so hopefully you substituted A, B, and C into your formula, then simplified your 3 chunks to get negative 9.4 plus or minus the square root of 152.36 all over negative 32. And when you solve for t, because of the plus or minus and your discriminant being positive, you will find 2 possible times where your ball hits the ground. Now, one of these times hopefully doesn't make sense to you. It should not make sense that one of your times is negative. We never measure time in a negative amount. So this solution really doesn't make sense. And what's going on here is because this ball is hit above the ground, we're playing tennis here, so maybe the person hitting it, it was served to them and then they hit it back. That ball never actually reached the ground in the beginning, and then it went up, but on the way back down, whoever they're playing with missed it, and then it hits the ground. What this graph would represent is actually, if I continued the parabola, the other root would be over here at a negative time. And so this portion actually never exists in this tennis scenario. It actually never happens. So this portion of our parabola here to the left is kind of not applicable based on the scenario of playing tennis. So there's really only one solution that makes sense, but no matter what you got, the second time that you're finding, the larger time is going to be the one that expresses when it hits the ground after having traveled through the air. So even if your ball did start on the ground and was hit, you would still have 2 roots. The second one would be the one describing when it hits the ground. So after it's traveled through the air. So the time it would take would be approximately 0.68 seconds for that tennis ball to hit the ground. All right, here's our next example. So the consumption of bread and cereal in the United States is increasing and can be modeled by the function y equals 0.059x squared minus 7.423x plus 362.1, where y represents the consumption of bread and cereal in pounds, and x represents the number of years since 1990. Since 1990 is going to be important here. But x really represents time, and y represents the consumption of bread and cereal in pounds. So getting jammed up here. So y is represented by pounds. All right, so let's look to our first question. In what future year could we expect the average American to consume 300 pounds of bread and cereal? So 300 pounds right there should tell you or link up with the y variable. So right away, this means to replace y with 300. We also know that y should be the one we're replacing because it's asking in what future year. Well, that's a unit of time. So time we should be looking for, not finding. So what we'll do is replace y with 300. And from here, to solve for x, to solve for the time, you need to set equal to 0 and factor if you could, because we're dealing with decimals, we'll go straight into our quadratic formula. So when we subtract 300 from both sides to set equal to 0, we're left with this equation right here, where a, the value of a is 0.059, the value of b is negative 7.423, and c is 62.1. These aren't the prettiest numbers, so we'll definitely be using our calculator to help us with this. But as long as you have A, B, and C identified, you can fill those portions into your quadratic formula and just type in your 3 chunks separately, very carefully with parentheses to simplify to get your next portion of quadratic formula. So let's go ahead, fill in negative b plus or minus the square root of b squared minus 4ac all over 2a. When you simplify your chunks, we get 7.423 plus or minus, and then the discriminant becomes 40.445 when you do all of this here. And then 2 times 0.059 is 0.118. All right, so then you can find your two roots or solutions. So x, and remember this is your time in years here, is either 116.8 or 9.01. This is where we need to come back to the word problem because it says x represents the number of years since 1990. So if we're looking for in what future year, the year is not going to be the year 116. It's going to be since 1990, 116 plus that amount, or plus 1990 plus 901. All right, so I have a little note here that because we're not fully into the next year at 116.8, that's not fully 117 years, we will round down because that will tell us exactly when we would hit at least 300 pounds of consumed bread and cereal, and same with the 9. So from here, I'm going to use my selection tool. We will take 1990, and one of the times we will add 116, and the other time we'll add 9. So this will happen at about 2106 or 1999. If you're in 1990, then we're probably concerned with the first one, the 1999, but these are 2 times where we'll hit the 300. And I think what we're going to see here with this type of scenario, the reason there's 2 possible scenarios is because we'll reach a maximum amount that we can consume bread and cereal, and then it might come back down. Okay. And next problem. Here's our 4th example. The path of debris from fireworks when the wind is about 15 miles per hour can be modeled by the quadratic function h equals negative 0.04 x squared plus 2x plus 8, where h is the height and x is the horizontal distance in feet. So x is distance in feet, h is height, h is again your y, distance is our x. So how far away from the launch site will the debris land? Well, debris landing is another scenario of being on the ground, so that means your height is 0. So take a moment, replace h with 0, and go ahead using a, b, and c, your quadratic formula, solve for the times at which your debris will land on 0. So click pause, or your debris will land on the ground. Click pause, and then when you're ready to check this, click play. Okay, so you replaced h with 0, a, b, and c you found to be negative 0.04, b was 2, c was 8, and replaced all those into your quadratic formula. And you should have gotten these 2 values for x. Now remember, x is a unit of, in this case, feet, a distance, and we never measure distance in negative amounts, so this solution does not make sense. The only solution that makes sense is 53.72 feet. So how far away would it be from the launch site? It would be 53 and 72 feet away from the launch site. With this same problem, we've got a follow-up question. At what height was the rocket launched from? Well, the height it's launched from represents a starting point, a starting height. And we've seen starting points already this unit, but a starting point represents where your time, or I'm sorry, in this case, your distance from the starting point would be 0. It has not left the launching pad or wherever we're starting from. So if your distance is 0, that means you would replace your x's each with 0 to solve for the height when the distance from it was 0. We've also talked about how a faster way to find this is just to state what your starting point is always going to be your C value, which is 8. And that should make sense because if your distance is 0, that means you're doing this times 0 plus this times 0. So 0 plus 0 is 8. So C always represents our starting point. So here we are, if we're starting up here at 8 feet for this launching situation, what that means is they're probably launching from a platform somewhere 8 feet above the ground. And while yes, this would continue in the other direction, this portion of our graph would not make sense in this scenario. All right, and here's our last example problem. A concrete walkway of uniform width is constructed around a rectangular garden measuring 9 by 12. The area of the garden and walkway combined is 72 meters more than the area of the garden itself. How wide is the concrete walkway? So before we get too far into this, it's probably helpful to have a visual of what's going on here. So we've got a concrete walkway of uniform width. So I could call that width maybe X. Going all the way around a garden, here's our garden inside, measuring 9 by 12. We could, meters it looks like. So if it's a uniform width, that means this length is X all the way around. And so here is a better picture of that uniform width going all the way around. And since we don't know what that width is, we can just call it X or a variable. I know it's not drawn exactly to scale, but imagine that these are the same length. So let's say this garden was like 3 feet going all the way around. It means X's length would be 3 everywhere around this garden. So then we're wondering, how wide is the concrete walkway? Well, if we're wondering how wide the walkway is, we're looking for X. What would X be? So a way to set this up, we know the area of the garden and walkway combined is 72 meters, is we can find the area of the big outside rectangle because we know that whole area would be 72 meters. So what we'll need to do is write expressions for the length and width that would multiply to give us 72. 9 by 12 would not give us that 72 meters. Oh, I'm sorry. Okay, this is making more sense. I'm not reading it properly. Sorry. The area of the garden and walkway combined is 72 meters more than the area of the garden itself. Okay, so the area of the garden we can certainly find because 9 times 12 is 108. So we know the area of our garden is 108, and then it's telling us that the area of the whole combined big rectangle of garden and walkway would be 72 more than the area of the garden. So if we've got our area of the garden at 108 and we add 72 to it, that means the area of this big rectangle is 180. So let's set up expressions for the length and width of the big rectangle. The width, it could be written as we've got 9 feet here, or 9 meters in this case here. And then we're, to get this big width, so this portion from here to here is 9. To write the expression for the big width, we can't forget about the walkway's width of X on both sides here. So this is really 9 plus an X, or distance of X's, which is 2X's, so 9 plus 2X there. On the length, we've got from here to here, we know that length is 12. And then to finish out the big length, we've got distances of X on both sides of 12, so 12 plus 2X for the length. Okay, so we found the new area to be 180, and we can set up now our length times our width to be equal to that 180. In this problem, we then need to simplify and set equal to 0 to solve for what X would be. So multiply your binomials together. You've done plenty of that this year to get 108 plus 18x plus 24x plus 4x squared equal to 180. And let's combine, simplify, and I like to put it now in standard form or descending order. and set equal to 0. So I'm doing this portion a little quickly on your paper. Hopefully you're combining your x to the first terms, subtracting 180 from both sides to set equal to 0. I've done this all in one step. From here, we need to factor if we can. All of our other problems have used quadratic formula today because of decimals. This doesn't have any decimals, so do see if it will factor, because that will go quicker. We have a GCF of 2 that can be pulled out. So go ahead and pull your 2 out of each term. And then we've got 2x squared plus 21x minus 36, which is a trinomial with a coefficient. So off to the side, you'll do 2 times negative 36, which is negative 72. And look, factors up of negative 72, that would add up to be 21. And so your factors would be 24 times negative 3 will add up to be positive 21, and they multiply to be negative 72, and we finish by grouping to fully factor. So when we finish factoring, we get 2 times 2x minus 3 times x plus 12 equal to 0. Take each factor, set each factor equal to 0. Remember, this 2 doesn't have a variable to solve for, so in this step you can kind of ignore it, even though it does need to be there. And get x to be either 3/2 or negative 12. Well, it doesn't make sense that your walkway is negative 12 feet, or I'm sorry, meters, I keep saying feet, is negative 12 meters. It doesn't make sense to have a negative distance at all. So the only answer that makes sense is 3/2, meaning that your walkway is 3/2 meters, or 1.5 meters. So that's a way to set up one of these problems and use your factoring methods to solve. When it's not necessarily a path traveling through the air, but it's still a use and application of quadratic equations, so equations that have exponents higher than 1, and solving for those. And that's the end of our lesson for today.